In 2019, an investment platform distributed end-of-day portfolio valuations to several thousand clients. The report had been built correctly. The data it was built from had not been read correctly. Equity prices were fetched from a pricing service at 16:02. Position data was read from a positions table at 16:08. In those 6 minutes, overnight transactions had settled. They had updated positions, but not the prices already pulled for the report. The valuations reflected a portfolio state that had never actually existed, a picture assembled from two different moments in time. The report was accurate. The moment it described did not exist. Temporal consistency is the requirement that a set of records reflects the same point in time, not approximately the same moment. The same moment. When you assemble data from multiple reads to produce a result, every one of those reads needs to describe the same instant. If any read describes a different instant, the result corresponds to no real state the system was ever in. This does not feel like a data problem when you encounter it. It feels like a calculation problem. The numbers do not add up. The report does not reconcile. A total seems wrong, but every individual value, checked in isolation, looks right. That is the signature of temporal inconsistency. Every piece is correct, but they were correct at different times. You have assembled them as if they were correct at the same time. 3 patterns produce this reliably. The first is red skew. Red skew occurs when a process reads multiple records while some of those records are being updated between reads. The first read captures a value as of time t. By the time the second read runs, the data has moved to t+1. The process now holds values from 2 different states of the system. In databases without snapshot isolation, this happens silently. Any query long enough for another transaction to commit mid-execution is at risk. The second is query composition. Many systems build results by assembling data from multiple queries, multiple tables, or multiple services. Each query runs separately. Each runs at a slightly different moment. A dashboard pulls live transaction data from one query and daily summary totals from another. A report joins a live orders table to an inventory snapshot computed earlier that morning. Each query is correct at the time it runs. Together, they describe a reality that never held. The third is propagation lag. Derived data, aggregates, summaries, cached values, materialized views, is computed from source data at a specific moment. The source data moves forward. The derived data does not move until it is recomputed. If both appear in the same report or query, the derived data reflects an older state, while the source reflects a newer one. Using both together, as if they describe the same moment, produces temporal inconsistency. The gap is not a bug, it is a design choice, but it has consequences when ignored. 3 things address this. The first is snapshot isolation. Most relational databases offer snapshot isolation as a transaction isolation level. Under snapshot isolation, every read within a transaction sees the same consistent version of the data, the version that existed when the transaction began. Reads at different moments within the same transaction do not see updates committed after the transaction started. Enabling snapshot isolation for long-running reads and reporting queries is the most direct way to ensure that all reads within a single operation describe the same point in time. The second is explicit timestamped alignment. When snapshot isolation is not available, across services, across databases, or across different systems, record when each piece of data was last updated. Before assembling a result from multiple sources, check that all of them fall within an acceptable time window. If prices were fetched at 16:02 and positions were read at 16:08, decide whether 6 minutes is acceptable for this computation. If it is not, wait for fresher data, recompute, or surface the gap rather than silently producing a mixed result. The third is frozen snapshots for reporting. For analytics and reporting workloads, the cleanest solution is to not read from live data at all. Compute a snapshot of the relevant tables at a defined moment, write it to a separate reporting store, and run all reports against that. The snapshot does not change while reports run. Every query against it reflects the same moment. This adds operational complexity. The snapshot process needs to be reliable and timely, but it eliminates the class of inconsistency that comes from reading live data across multiple separate queries. The investment platform resolved the immediate problem by rerunning the affected valuations with prices and positions read from the same point in time. The structural fix was a coordinated snapshot. At market close, relevant pricing and position data were written to a reporting table in a single operation. All valuations were computed from that. Clients received revised reports the following morning. Temporal consistency does not require the data to be wrong. It requires the data to be read from different moments and assembled as if it describes the same one. Your database will not prevent this. Your schema will not flag it. The query returns values, the report renders, and the result looks exactly like one that was computed correctly, because every individual value was. The inconsistency is not in any single record. It is in the assumption that records from different moments can be combined into a picture of a single moment that never existed.